This video is on compound inequalities, and we're going to first focus on OR inequalities. So in the previous lesson, in lesson 3, we talked about if the inequalities were joined with the word and. So in this lesson, it will have the word OR. And then we will end with review from lesson 3 and this lesson. So the word OR indicates the union of two sets. This includes all the solutions from each set, not just the common solutions. So in the previous video, when you graphed your solution, so I'm just making this up here. Let's say this one went this way, and then this one here went this way. You wanted to include where they both have, the solutions they both have in common, because that's what the word and means. So since both of these go in this section here, your answer is only this part here. Okay, so now we're saying that if it has the word or, we're going to include all the solutions. So not just where they both meet, but even these ones over here. So the symbol for OR, it looks like a horseshoe or a U. So that's the symbol for OR. So it means we're taking two sets and taking the union of two sets. That's when we would use this symbol. So let's do a non-math example. So let's say that this circle right here represents birth certificate. Okay, then the other circle, let's say, represents passport. And I tell people, come stand over here in this section if you have your birth certificate. Stand here, see how this part is in both circles? Stand here if you have both with you. And then stand over here in this part of the circle if you just have a passport. So imagine a bunch of people moving in the correct spot. So it says, you must have your birth certificate or passport to travel to Hawaii. So because it has the word or means you don't have to have both. So these people would get to go on the plane. So if you had to have one or the other to travel to Hawaii, these people would get to go on the plane. These people came overly prepared. They have both, but they're going to get on the plane. And same with these people. So that's the difference. The word or means include all the solutions. Whereas if it said and, only these people would get on the plane, because and means you have to have both. Okay, so now let's apply this with some math examples. So it says solve and graph the compound inequality. Write your answer in interval notation. So first of all, we see the word or. So whether it says and or if it says or, you're going to solve both the inequalities just like normal. So remember from lesson 2, when you are solving inequalities, if you divide or multiply by a negative, this symbol switches. So the first step is I want to get the x by itself. So we're going to add 4 to both sides. And then because this is a fraction, instead of dividing, we multiply by the reciprocal, because this would make 6 divided by 6. So that's why these go away and make 1x. Now whatever you do on this side, we have to do on this side. So then we would do 6 times 3 halves. So 6 times 3 halves, which is 9. Now without a calculator, to review multiplying with fractions, this 2 goes into 2 once, and 2 goes into 6 3 times. So then you're left with 3 times 3 is 9. Okay, so now we're done with this one. Now we have to get the x by itself over here. So the first step is to simplify. So we're going to distribute, and that means multiply. So that's negative 3 times 1. So we have negative 3x, and then we have negative 3 times 1. So that's negative 3. Okay, now we want to get the x by itself. So I'm going to add 3 to both sides. And then lastly, divide by negative 3. When we divide by a negative, that's what's going to make the symbol switch. Now 3 can't go into 8 evenly, and nothing divides into 8 and 3. So it's going to stay 8/3. And then a positive number divided by a negative is a negative 8/3. So we don't leave the negative ever in the denominator. We either put it out in the front or with the top number, because a positive divided by a negative is just a negative. That makes the whole number negative. Now, if you do it with your calculator and you do 8 divided by negative 3, it gives you the decimal. Since the decimal goes on and on and on, we can't leave it in a decimal form. We can't put negative 2.6 with a line on top. In math, we never round unless it tells us to. So we can't leave it as a decimal. So then I'm going to click second FD, and now it's going to change it to a mixed number. So you could also have as your answer here negative 2 and 2/3. And then if I click second ABC, again, that converts it to negative 8/3. So either of these would be okay. Okay, so now what we're going to do is I call this a rough draft. I want to do a rough draft. I'm going to put both the graphs together. And our rough draft sometimes will be good enough to be the final draft, but this is going to be my final graph. So I'm going to do a little sketch here, and because I have to include all the solutions. Some of them might overlap, and I need all the solutions. So the first thing I'm going to do is I'm going to start with the negative 8/3 because it's smaller. The smaller number goes on the left side, and then the greater number is going to go over here on the right side. And then I'm going to graph this. This says shade all the numbers that are greater than or equal to. So because it has this line underneath, I'm going to use a bracket. But because I don't know right now like what way, I'm just going to put a little circle and I'm going to shade it in because it has the line underneath. And then I'm going to need a bracket here. So it says shade all the numbers that are greater than or equal to 9. So I know that the bracket will go this way. So again, you don't need to have a bracket and the shaded circle. You can just have the bracket. Okay, now the next one says shade all the numbers that are less than negative 8/3. Less than or equal to. So I'm going to need a solid circle or a bracket, and it says shade all the numbers that are less. Okay, so because this is an or inequality, we want to include all the solutions. So we want to include all of these, and we want to include all of these. So there's no overlapping. So this is actually, instead of a rough draft, this is actually our final answer. So I'll show you one in one of the upcoming examples where you'll see why we needed to do the rough draft. So for this one, it was actually our final answer. So now our interval notation, we always go from the left to the right. So we start here, and we could see that the graph is going infinitely to the left. Well, these numbers are getting smaller and smaller and smaller. There's eventually going to be negative numbers over here. So that's why we put negative. And we always put a parenthesis around infinity. Then we put a comma. And then as we go to the right, it stops here at 8/3. And we put a bracket because there's a bracket here. And then we have this gap right here with no solutions here. That's when we're going to use this symbol here, the union symbol. It's saying that x can be any number here or any number over here. So then we go left to right. So we're going to put a bracket, 9, comma, and then it's going infinitely to the right, and we always put a parenthesis around infinity. So again, this is called interval notation. Okay. All right, so let's go ahead and try another example here. So we have 2x plus 5 greater than or equal to 5. So we want to get the x by itself, so we'll start by subtracting 5 to both sides. And then lastly, to get rid of this coefficient, we divide both sides by 2. And we get x is greater than or equal to 0. So here's my rough draft. And I'm going to wait to graph it because this is a compound inequality, so now I need to do the other one. So x plus 3 is greater than or equal to 6. So to get this x by itself, I'm going to subtract 3 to both sides. Okay, so I'm going to start with the 0 because it's smaller, and then 3 is not too far away from 0, so I'm going to put it right there. It has the line underneath, so that's how I know I'm going to put a solid circle here or a bracket. And this one also has a line underneath, so it's going to be a bracket. Okay. Now I read this. This says, shade all the numbers that are greater or equal to. So the equal to part just means it's going to be a bracket. So all the numbers are greater over here on the number line. So all the numbers here are greater. Okay, now here, this one says, shade all the numbers also that are greater or equal to 3. So that means all of these numbers are shaded. Okay, now because this is an OR problem, we want to include all of these answers. So this rough draft is going to help us now get the final draft. So we're going to have a 0 with a bracket, and then everything to the right is completely shaded. So we don't need this 3 and we don't need this bracket or this circle because it's already shaded. 3 is going to be over here and it's already shading means a bracket. So all of these are brackets essentially. So the shading here is already including this 3. So that's why it's like unneeded. Okay, so this is our graph. So this is not the answer that helped us get our answer. Okay, so now to write our interval notation, we're going to go from the left to the right. So from the left, starts at 0, comma, and then goes infinitely to the right side. Okay, so this would be our answer for this problem. Now, just to practice what we did yesterday, if it had said and instead, the answer, if it had said and instead of or, would be here. This part of the graph is where both of them are shaded, so the answer would be bracket 3, comma, infinity. So as we go through these problems, I'm going to compare it to what we did in lesson 3. So this is the answer if it was or, which this problem is, and this is what it would be if it was and. Also, I want to go back to problem 1. I just noticed here that I wrote over this. I kind of covered up the negative here. So this should have been a negative 8/3. So I just want you to go back to problem 1 and fix that. Okay.